Okay, I had a few questions. A couple of students sent questions about regarding this question. This is question number 10 in your book, or not in the book, excuse me, on the My Math Lab account. My pencil's not working. Hold on. Okay, so this is question number 10. My stylus still isn't working very well, you guys. Let me grab another one. Hold on. Okay, so with this question, it's going to take me a minute to write it down, but we want to remember the rules of exponents. And a few individuals said they were having trouble, quote unquote, foiling this. FOIL is only used when you have two binomials that we're trying to multiply, but I'm going to show you that we don't even have to multiply this out in the beginning. Okay, the first thing that you want to do, of course, is get rid of this negative 1 on this side, whichever side you decide, but we want to get rid of this, right? So we're going to use opposite operations. We're going to add 1 to both sides, and when we do that, what we get is x plus 2 cubed equals x times x plus 2 times x plus 4, right? So now let's look at the right-hand side for a moment. Over here on the right-hand side, over here, come on, Ben. On this side here, all of this represents one number, okay? It may be hard to visualize that is one number, but think about it. You have this x, this is some number, right? And once we add 2 to it, this is going to be a different number, right? And then this is a different number. So we've got these three numbers that are being multiplied. When we multiply numbers together, we end up with one number. So you can look at this whole grouping as one number. So I am going to move this entire number by subtracting it from both sides to the other side. All right, and so what we're going to get is x plus 2 cubed minus x times x plus 2, x plus 4, and it's going to be equal to 0. So we're almost in quadratic form. Now, the other thing, I think this was the main thing that was giving a lot of people a pause, is this binomial cubed. You don't have to multiply this out. What you can actually do is expand this. So let's expand this for a moment into x plus 2 times itself. And then we're still going to have this minus x times x plus 2 times x plus 4. And this is equal to 0. So now, what we have now are two terms. They're not pretty terms, but they're terms, right? Because they're separated by that minus sign. There's one term, and here's another term. So for a moment, let's consider if we had something like 4x plus 8 equals 0, right? The idea behind it is that we want to find our GCF. If we weren't going to subtract, we would look for a GCF between these two terms. And the greatest common factor that the 4x has in common with this 8 is a 4. So if we pull the 4 out, we're left with x plus 2. Does everybody see that? Okay. Well, we can take that same thinking that we did here into our problem. We can look at these two terms and ask ourselves, what factors do they have in common? What's their greatest common factor? And what I see, and I hope you do as well, is that there's an x plus 2 in this factor and an x plus 2 in this factor. So I see two x plus 2's that they have in common, right? Or an x plus 2, not 2, excuse me. They have an x plus 2 in common. So what I'm going to do is I'm going to pull that x plus 2 out to the front of this. And then we're going to tell ourselves, what do we have left? Well, we only have two of these remaining now, right? So I have an x plus 2 times an x plus 2 here. And over here I have x times x plus 4. Okay? So now inside parentheses, now you can do your FOIL that you want to do right here, right? We can do that, and we're going to see that some things are going to cancel out once we utilize that. Trying to get that off. Okay, let's erase it then. It wouldn't undo, so I'll just erase. Okay, so what we're going to do, we're going to leave this factor of x plus 2 out to the front. And I think you guys are going to start seeing the magic happen here. What we're going to do when we distribute, the distributive property is all what full is only the distributive property, okay? I'm not a fan of the word full, but you guys like it. But remember, it only works when you have two binomials. But it's just the distributive property. Okay, so since that's just the distributive property, let's distribute this. And what we are going to get is x squared plus 2x plus 2x plus 4. And then when we distribute our x here into that other factor of x plus 4, we'll get a minus x squared, because it's a minus x, sorry. We'll get a minus x squared minus 4x. Okay? So, and what you'll know, if you notice now, we can start eliminating some terms on inside these brackets. Notice that this x squared and this x squared are opposites, so those go to 0. The 2x plus 2x gives me 4x, but then there's a minus 4x over here, so that goes to 0. So what I'm left with is the 4 inside the bracket and the x plus 2. Okay, and if you want to move the 4 to the front, you can. And this equals 0. And notice this now looks like what we have here, right? Okay, so I'm going to erase the arrow here. Alright, so we can divide both sides by 4. My pen back. Divide by 4 on both sides, leaving us with just x plus 2 equals 0 divided by 4, still 0. We'll subtract 2 from both sides, and we end up with x equals a negative 2. Now, please note, if you don't like this method, I'm going to show you how to multiply, since a lot of you guys like to, well, I guess like's not the word, but that is what you are really trying to figure out how to multiply. But I wanted to show you first that you didn't have to multiply things all the way out. But on the next slide, I'm about to switch slides, and we're going to do this problem again, and I will show you the steps in multiplying it out. Okay, so hold on just a second. I think it's going to start my recording over. Hold on. Okay, so it starts with me recording on this slide, but I think they'll run together when it's playing. It's the first time I've really used this app for recording. But let me add in the problem again. Okay, I'm back with you. Okay, so here is the problem again, and let me show you how to multiply this out. So remember, on the left-hand side, I had expanded that x plus 2 cubed, right? Because that's what that exponent tells us, is that we're taking that base, and our base in this case is the parentheses, and we're going to repeat it that number of times. We're going to repeat it 3 times and multiply, right? And I'm working from the step where we've already added our 1 on both sides, by the way. Okay, so looking at the left-hand side, I am going to just use the distributive property here, and then when I'm only multiplying these two together, since I have two binomials, this is what you all like to call full, but again, it's just the distributive property. So I'm going to leave that first x plus 2 alone, and when I FOIL this, we'll get that x squared plus 2x plus 2x. I'm going to go ahead and combine those two x's together to give me 4x. And then, so that was the x squared, right? Plus the 2x, and then plus the 2x here. And now when I multiply the last numbers, distribute that 2 in there, we get a plus 4. Okay? And over here, we can also go ahead and use the distributive property, or FOIL, also known as FOIL, for two binomials. And this is going to give me x squared when we distribute here. And then we'll have a plus 4x. And then when we distribute this, it'll give us a plus 2x. So inside, we're going to have a plus 6x when those two terms are combined. And then the last two terms are, yes, the last two terms when we multiply, their product is going to give us a plus 8. Okay? So, now, what if you want to continue to multiply, which you'll need to if you're multiplying out instead of doing what I did on the first slide. Excuse me, I'm sorry. You will need to use the distributive property. So we're going to distribute this x in here. So the distributive property is kind of like, let me say it this way, it's kind of like the United States Postal Service, okay? And no matter how many houses are in your neighborhood, so anything in your parentheses over here is what I'm referring to as your neighborhood. No matter how many houses are in here, he's got to deliver the Walmart circular to each house, and he's got to deliver the Kmart circular. Okay, Kmart's gone. Maybe we should use someone else to each. Okay, but anyway, so the mailman has to deliver these circulars to each house in the neighborhood, right? So the Walmart circular, whoops, sorry, I dropped my pen somehow and pick that back up. Okay, so the Walmart circular has to go to this house, right? And that'll give us x cubed. And it has to go to the next house in the neighborhood because everybody gets those advertising circulars, right? So we're going to go over here, right? So it gives us plus 4x squared. And when we distribute it to the last house, we get plus 4x. He also has to deliver that other circular, which I called Kmart, right? It's gone now in Madisonville. But that gives us 2x squared plus 8x plus 8. So we have multiplied that trinomial and the binomial together using the distributive property, okay? And we're going to use the distributive property here on the other side as well. Only one circular to deliver, right? Only one advertisement. This is going to give us x cubed plus 6x squared plus 8x. All right? So when we start combining our like terms here on the left, we get x cubed plus 6x squared. I'm going to cross some things out so I don't forget anything or use anything twice. And that's a good habit to get in, you guys. Plus, looks like 12x plus 8. Okay? So I use those, and I use that one. Okay. And we still have the same thing here on the right. X cubed plus 6x squared plus 8x. And if I'm now going to subtract all of the stuff here on the right and basically, quote unquote, move it to the other side, right? Because this is positive, this is positive, and this is positive. So I can subtract all of those things. And when I subtract x cubed from both sides, well, this one goes to 0, right? And when I subtract 6x from x squared from both sides, this one will go to 0, right? Leaving me with 12x minus 8x, which gives us a 4x plus 8. And if you recall, that's the same thing we got on the other side. And instead of pulling out the GCF, I'm just going to subtract 8 just to show you that we still get x equals a negative 2. So it's your choice whether you decide to use the first method or the second method. The second method is geared more towards what you all have been doing. I hope this information was helpful, and if you have any questions, please feel free to contact me. Thanks and have a great evening.